All right, hello again, Algebra. So now we are ready to do section 6.6 in your book. Now we're going to solve quadratic equations using factoring. So now you're going to find out why have we been doing all these factoring skills. So before you even start today on this, I would like you to now read pages 482 to 487 just so you kind of have an idea of what I'm talking about before I talk about it. All right, so once you've done that, come back to the video, please. All right, so I want you to look at these two equations. So one of them is a linear equation and one of them is a quadratic equation. So what in the world is the difference? So a linear equation, if I had you graph the top equation, now you may be saying, well, how could I graph it? There's no y in it. Well, technically, if I bring that 6 over and make this 2x minus 3 equals y, then it becomes a linear equation, okay? But if you look at the second problem, which means, by the way, before I move on, that would mean it would graph a line. So the second equation, if I replace the 0 with a y, if I graphed that, which you don't know how to do that yet, that would make a parabola, or a parabola that goes up. Okay, so the difference between a linear equation and a quadratic equation is when you graph them what they make. So a linear equation makes a line and a quadratic equation makes a parabola. So eventually we're going to learn how do you graph those, okay? The other thing you need to know is a linear equation only had one solution at most, okay? Sometimes they even had no solutions. Now I take that back. Sometimes we had special cases that had all solutions, yes. All right, but x squared plus 5x plus 6 equals 0, a quadratic equation, has two or more solutions. Now, I will tell you that if it graphs as a parabola, which means it has an x squared on it, it only has two solutions. But if I had a quadratic equation that was said x cubed on it, which you might see those, then those are going to have three solutions. Okay, I think I said equations and I didn't mean to. I meant to say solutions. Those don't graph parabolas, they graph something else. That's all for Algebra 2 next year. So, but today we're not doing anything with graphing. That's going to be the last week of school. That'll be fun. I'm hoping we can do a live session for that because those take a little while. But today we're going to talk about, well, what does it mean to solve a quadratic equation using factoring? Again, this is going to show you why in the world did we learn all those factoring methods for the past, I don't know, forever. All right, here we go. So I just wrote something funny on the screen. A times B equals 0. So if we were in the classroom right now, I would say to you, if I say A times B equals 0, what does that tell you? Well, one of you lovely people would have said, well, that means either A or B have to be 0. Because of the 0 property of multiplication. If something times something is 0, doesn't one of those have to be 0 to make an answer of 0? The answer is yes. Now, could A and B both be 0? Yes. So either A is 0 or B is 0. Or in rare cases, A and B are both 0. Okay? We're going to use this concept to solve quadratic equations. Let me show you what I'm talking about. So here's our first problem. X squared plus 5x plus 6 equals 0. So if I'm solving this equation, what I want to do is I want to find out what in the world does x have to be to make this a true statement. Okay, well, we're going to find out. If this were an equation, like if it was 5x plus 6 equals 0, we would be finding out what does x have to be. But instead, we have to find out what does x have to be to solve this equation. We've got an x squared involved, which makes things kind of weird. So first of all, I want you to step back for a second, and I don't even want you to worry about that equal sign. I want you to worry about what's on the left-hand side. So if you just focus on this, x squared plus 5x plus 6, and I said, hey, factor that for me, I would hope all of you would come up with this. X plus 2 times x plus 3. Because that's what we would have done for factoring. But see, now it equals this. So now what we're going to do is we're going to use this concept that I wrote at the top of the page. A times B is 0, so either A is 0 or B is 0. So if you look at this, we could figure out what could X be to make this problem true. So to do that, we do this. We say, what could make X plus 2 equal 0? Or what could make X plus 3 equal to 0? Okay, well, think about it. X plus 2 equals 0. Very simple one-step equation. You subtract 2 from both sides. So X is negative 2. So I want you to think about that for a second. If X were negative 2, go back up here to this point right here. So if I plugged in X is negative 2, think about this. Negative 2 squared is 4. 5 times negative 2 is negative 10 plus 6. So 4 plus negative 10 is negative 6. Negative 6 plus 6 is 0. Oh, that's a solution. Well, what about X plus 3 equals 0? So if I subtract 3 from both sides, X is negative 3. So what's that mean? So if I go back to where I just was, okay, and I'll use a different color. If I said, what is negative 3 squared? That's 9. 5 times negative 3 is negative 15 plus 6. 9 minus negative 15, or not, I'm sorry, 9 plus negative 15 is negative 6. Negative 6 plus 6 is 0. What this means is there are two solutions to this problem. Either X is negative 2 or X is negative 3. If X is either one of those numbers, that problem equals 0. So that's the solutions to the problem. And notice it says or, not and. Why doesn't it say and? Well, X can't be two numbers at the same time. All right, so this quadratic equation had two answers. And the way I know it has two answers is there was a squared there. That tells me I better have two answers. If there was a cube there, I better have three answers. Those will come later. All right, so I'm sure right now your head is probably spinning. So I'm just going to show you. Let's keep going. All right, so here's the next problem. We want to find out, what does X equal? Okay, so first of all, what I haven't told you yet, and it's not going to come into play yet, is you can't solve a quadratic equation until one side is equal to 0. Okay, well, that step is already marked off. We're in good shape. So the next thing we're going to do is we're going to look at that trinomial and we're going to think, can we factor it? Well, does it have a GCF? No. So it's a trinomial with a 1 in front, so I need to go ahead and try to factor it. So for some of you, maybe you have to do the little chart thingamabob that, let's see, we need two numbers that multiply together to be positive 12 and add up to negative 13. Others of you, maybe you just figure it out. It's negative 12 and negative 1. So my answer is X minus 12, X minus 1. Now, when we were factoring, we'd be done, but we're not done. So this equals 0. So how do I find my two solutions? Once I'm in factored form, it tells me exactly what I'm going to solve for. So I'm going to say X minus 12 is 0 or X minus 1 is 0. Because the point is, either this quantity has to be 0 because something times 0 is 0, or this quantity has to equal 0. So I need to figure out what would make those quantities 0. So what would make X minus 12 equal 0? Well, X would have to be 12. Because think about it. If I put 12 here, 12 minus 12 is 0. 0 times whatever's in the second parentheses is going to be 0. On my second one over here, add 1 to both sides. X is 1. So if X were 1, this quantity would be 0. Doesn't matter what the first quantity is. It would still be 0 times something is 0. And again, you could check your answers back in the original problem. So if I take 12 and I plug it back into the original problem, 12 squared is 144 minus 13 times 12 is 156 with the help of my calculator plus 12. So 144 minus 156 is negative 12. Negative 12 plus 12 is 0. If I take my 1 and I plug it back in the original problem, 1 squared is 1 minus 13 times 1 is 13 plus 12. Oh, look, that equals 0 too. So my answer to this problem, you always put the word or, is either x is 12 or x is 1 are the solutions to that particular problem. Now, I threw in a different looking problem so that you can see in the future some things that are going to happen. So look at this problem. No, I'm not going to start by multiplying it out because guess what? It's already in factored form and it's already equal to 0. So this problem, I don't have to factor. I'm ready to actually find the solutions. So what I'm trying to find out is what could this be to make this equal to 0? So what could t be so that something times something times something is 0? Well, think about it. If something times something times something is 0, one of those terms has to still be 0. So I need to figure out what would make this term 0, and I need to figure out what would make this term 0. So this problem has 3 answers. So let me show you how this one works. So the first one I'm going to do is I'm going to deal with this little t out front. Well, I'm just going to let it equal 0. I don't have to solve anything. So think about it. If t were 0, then that would be 0 times, well, it would be 0 minus 6 is negative 6 times 2 times 0 minus 3 would be negative 3. 0 times something is 0. All right, the second parentheses, what would make this one 0? Well, if I add 6 to both sides, t is 6. So now I have 2 solutions. T could be 0, t could be 6, or in this last set, 2t minus 3 equals 0. And this one takes a little more work. Divide by 2. T is 3/2. So I have 3 solutions to this problem. So in this problem, if t were 0, I would have something times something times something is 0. If t were 6, that would make the first parentheses, t minus 6 would be 0. So it would be something times 0 times something is still 0. Or in the last parentheses, if t was 3/2, then that would make the last term 0. So there's 3 answers here, and I should be putting ors between these. Okay, so 3 answers to that problem. So I just wanted to show you that's going to be what some of your problems start looking like here in a little bit. Okay? Okay, so up until this point in this chapter, I've been saying factor completely, factor completely. Well, now they're not going to say factor completely. They're going to say solve. So if you look at this problem and I said solve it, we can't solve it yet because I just told you a couple slides ago, you can't solve a quadratic equation until one side is equal to 0. And of course, you want to try to keep it in descending order too. So if I want to put this in descending order and I want to have one side equal to 0, first thing I'm going to do is subtract 20 from both sides. And I get 2x squared minus 3x minus 20 equals 0. So that's my first step. Now the second step is to be able to find the answers to this quadratic equation, I have to try to factor that trinomial on the left side. And of course, first thing I'm going to say to myself is there a common denominator? Common factor, not common denominator. The answer is no. So now I'm going to do my work and try to factor my trinomial. So what times what is 2x squared? 2x and x. What times what is negative 20? Well, I've got some possibilities here. There's some things I know I'm not going to do. Like I'm not going to put a 4 in that first parentheses because then I would have a GCF there. So let's just try 4 here and 5 here. And let's just try a minus here and a plus here. Would that work? So that gives me negative 5x and positive 8x. That gives me positive 3x. I want negative 3x. So that tells me all I need to do is switch this, and there's my answer. So far, not really my answer though, right? So I've already checked it. I've made sure that everything works. So now it equals 0. So now I've got to actually solve. So I set one side equal to 0. I factored. Now I'm ready to solve for my solutions. So either 2x plus 5 equals 0 or x minus 4 equals 0. So I got to solve both of these. So in the first one, I'm going to minus 5 from both sides. and I get 2x equals negative 5. Divide by 2. So x is negative 5 halves, or over here, add 4 to both sides. X is 4. So my two solutions to this problem are negative 5 halves or 4. So if x were negative 5 halves, this problem at the top would work. If x were 4, this problem at the top would work. And if you wanted to, you could check them, like if this were a quiz or a test, just by plugging those answers in and making sure they actually work. And if they don't, then you know you've probably done something wrong in your factoring. All right, so what if you had this one? Okay, well, first of all, one side's already equal to 0, so I'm ready to factor. Think about all my factoring skills. But if I look at 2x squared minus 72, my first thought is, oh wait, I have a common factor of 2. So what do I do with it? I factor it out. And I end up with this. But now I have to say to myself, okay, what can I do to x squared minus 36? It's the difference of two perfect squares. So here's how you write this, guys. 2x plus 6, x minus 6 equals 0. So now I'm ready to write my answer. So I know that somebody's going to go, wait a minute, what do I do with that 2 out front? Well, to be totally honest, that's not a variable, so that 2 doesn't mean anything. It doesn't mean it's a solution or anything. Now, when we were factoring, that 2 was very important. But right now, that 2 doesn't mean anything. So my solutions are x plus 6 equals 0, or x minus 6 equals 0. So subtract 6 from both sides, x is negative 6, or add 6 to both sides, x is 6. So the two solutions to this problem are negative 6 or 6. Now, I say that 2 is not important. Well, it was important that it took it out. Otherwise, I couldn't have factored that problem, okay? But if that would have been a variable on the outside, then I would have let it equal 0. Then you would have found out one of your answers would have been like x is 0 or something, okay? So hopefully that made sense there. I know I'm throwing a lot at you today. Okay, how about this one? So let's see here. What do you notice? Well, I notice it's already set equal to 0, so I don't have to do that part. I notice there's a common factor. I notice there's a common factor of 2a. So if I take out a 2a, I have 3a squared plus 4a plus 1. Okay? Okay, so now I can't say that I'm done, because guess what? I now have to try to factor this trinomial right here. So the 2a comes along for the ride for a while. What does this factor into? Well, let's see here. 3a and a, and it's a positive and a positive, so plus 1 and plus 1. Does that work? Check your middle terms. So let's see here. 1a and 3a, does that equal 4a? The answer is yes. I'm always going to check before I go any farther. So I have factored this problem. Now I'm ready to solve it. So what are my solutions here? So what do I do with that 2a? Well, in the last problem, the GCF was just a number. We didn't actually need it, okay? But this time, this is actually has a variable, so we need to say 2a equals 0, or 3a plus 1 equals 0, or a plus 1 equals 0. Now, hint, hint, look back at the original problem. Do you see how it said a cubed here? My hint right there is I know I have 3 answers, okay? So 2a equals 0. We need to solve that for a. So if I divide both sides by 2, a is 0. So what that means is, in that original problem, if I plug in a 0 for a, think about it. A cubed is 0 times 6 is 0. A squared is 0 times 8 is 0. 2 times 0 is 0. It would have worked. I can't talk. Or solve this next one. Minus 1 from both sides. 3a equals negative 1. Divide both sides by 3. A is negative 1/3. So my second solution is negative 1/3. So a, if I let a equal negative 1/3 and I plugged it back in the original problem and I cubed negative 1/3 and multiplied by 6 and I squared negative 1/3 and multiplied by 8 and I took 2 times negative 1/3 and I added it all together, it would equal 0. All right. And then last but not least, over here, if I subtract 1 from both sides, I get a is negative 1. So my three answers are a is 0, or a is negative 1/3, or a is negative 1. Now, I know that's kind of sloppy, but you really should circle your answers because there's so much work now, it's hard to find your answers if you don't. Okay, we're going to do one more today because I'm sure you right now, your heads are spinning. So, like, this is the hardest one for today. All right, so if I said solve this quadratic equation, what would you do? So I am guessing that some of you right now would say, oh, it's already factored. So I'm going to do 2x plus 5 equals 0, x plus 1 equals 0. The answer is no, because notice the equation doesn't equal 0. I can't start factoring anything until it's equal to 0. Others of you, I'm sure your thought would be, well, then I'll just add 1 to both sides. Well, if you do that, that's a great idea. So let's do that. Here's what you get. You get 2x plus 5 times x plus 1 equals 0. Now what? No, you can't set these equal to 0. We can't do anything now until it's like we're going to go backwards to go forwards here. If you've ever heard of the saying 2 steps back, 1 step forward, or 2 steps forward, 1 step back, that's kind of what we're going to do here. So I can't do anything until I actually FOIL 2x plus 5 times x plus 1. So I'm going to go back and multiply first. So 2x times x is 2x squared. 2x times 1 is plus 2x. 5 times x is plus 5x. 5 times 1 is 5. But then I'm going to bring down this extra plus 1, and it's going to be part of the problem. It wasn't part of the FOIL, but it is part of this work. So now I've got 2x squared plus 7x plus 6 equals 0. Now I can start factoring it because I have a quadratic equation equal to 0. Okay, do I have a GCF? No, almost, but that 7 threw a kink in there. So I want to try to factor this trinomial. 2x and x. Well, I'm sure not going to put the 2 from the 6. If I do 6 is 3 times 2, I'm not going to put the 2 with the 2 in the first parentheses. So what if I do plus 3 and plus 2? Does that work? If you check your work, 3x and 4x is 7x, so yes. Okay, so I'm factored. Now I'm ready to set them equal to 0 and solve. Okay, I'm going to run out of room here. So I've got 2x plus 3 equals 0, or x plus 2 equals 0. Now, I would guess for most of you at this point, you're like, oh, x is negative 2 is one solution. Don't even have to do the work for that. Be careful on the other one. I see some really stupid mistakes on the second one. So if I minus 3 from both sides, that is 2x equals negative 3. So x is negative 3 halves. You can't see that 3 there. So x is negative 3 halves. Those are my two solutions to this problem. So that one not only involved solving a quadratic equation, but you had to start with actually multiplying two binomials. So like I said, it's kind of like 2 steps back, 1 step forward here. All right. So again, I've thrown a lot of information at you today, and you've had a quiz this week. You've had a lot of algebra this week. So all you have to do is submit your notes. You don't have any assignments today or anything. We'll come back to this next Wednesday. Have a good weekend. You totally deserve it. I will get the quizzes graded over the weekend, and you'll see your results next week. Have a wonderful weekend.